In this video, we are going to find integers x and y such that y equals 2x squared plus 5xy plus 3y squared. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. I'm going to share two solutions to this problem. My first approach is that notice that the right side can be factorized, which is y equals 2x plus 3y multiplied by x plus y. I plan to so-called complete the squares. In fact, I'm going to multiply both sides by 8. I'm going to double this expression, 2x plus 3y, and multiply x plus y by 4. So then, for the left, we have 8y. Then for the right, we have 4x plus 6y multiplied by 4x plus 4y. Now we know how the completing a square works, which is 4x plus 5y all squared minus y squared. But that's not enough. I'm going to move the y squared to the left so that y squared plus 8y equals 4x plus 5y all squared. Then I'm going to further complete the squared for the expression at the left, which gives y squared plus 8y plus 16 equals to 4x plus 5y all squared plus 16. So simplifying, we have y plus 4 all squared minus 4x plus 5y all squared equals 16. Now we have difference of squared to be equal to 16. Now either we can just look at an equation of this form, difference of squared equals 16, or difference of integer squared equals 16. We have either 1 equals plus or minus 4 and the other equals 0, or 1 equals plus or minus 5 and then the other is either plus or minus 3. Then we can say that y plus 4 and 4x plus 5y take these 6 possible pairs of values. Then by solving, we have y equals 0, minus 8, 1, minus 9 for these cases, whereas for x, we have 0, 10, for this one is actually minus 1/2, so we have to reject. For the next case, we have 12, and for this case, we have minus 2, and for this case, we have 21/2. So again, we reject these cases, and we know that we have these 4 pairs of solution sets. We can choose to do this, or we've factorized the difference of squares at the left, so then we have y plus 4 plus 4x plus 5y all multiplied by y plus 4 minus 4x minus 5y equals 16. So simplifying, we have 4x plus 6y plus 4 all multiplied by minus 4x minus 4y plus 4 equals 16. Then we have 2x plus 3y plus 2 multiplied by x plus y minus 1 equals minus 2. So then we have fewer cases to consider because we're just looking at factors of 2. Then again, we can solve for x and y, and we get the same solution sets. So this is the first approach. My second approach is to treat this equation as a quadratic equation about the unknown x. We have x squared term, the x term, and some terms that are independent of x. We can treat them as constants, y as part of the coefficient. So we have 2x squared plus 5y times x plus 3y squared minus y equals 0. Then we can consider the discriminant of this quadratic equation about the unknown x. Notice that since we are looking for integer solutions, the discriminant, or delta, has to be a perfect squared. So then, by definition, we have 5y all squared minus 4 times 2 times 3y squared minus y is a perfect squared. Then simplifying, 25y squared minus 24y squared plus 8y is a perfect squared. Y squared plus 8y equals, now at this point I'm going to write this as say a squared some integer a. So I do not have to always use the square shape. So again, we can complete squares, and we have difference of squares again. It's just that this time we obtain this differently. And that means either the sum of y plus 4 and a, I should say both the sum and the difference is a factor of 16, the product equal to 16. So we can set up a system of equations and of course negative factors as well. But notice that because we want a to be an integer, and same for y, these two expressions, the sum and the difference, actually have the same parity. So we can't have cases like 16(1) or -1 minus 16. So we can cross them out. Fewer calculations required. Then we can solve the rest. We can add the two equations and then -8 and divided by 2. So then y equals the sum, which is 10 minus 8 divided by 2. So y is 1 for these cases. And then when y equals 4, that means when we have two 4s in the system, that means y is equal to 0. Whereas for the negative cases, we add them up, divide by -8 divided by 2. We have y equals -9 for these two cases, and y equals -8 when both expression equals -4. So again, we can put these numbers back into our original equation and solve for x. So altogether, we have these 4 solutions. All 4 of them are valid, which are -2 and 1, both equal to 0, 10 and -8, and 12 and -9. So this is the final answer. Please feel free to share your ideas in the comments. Thank you for watching. See you next time.